Researchers at the RIKEN Center for Brain Science in Japan have discovered a molecular mechanism that contributes to the development of Alzheimer's disease. Their study, published in the journal Molecular Psychiatry, shows that turning that mechanism off could be an effective and relatively cheap new way of combating Alzheimer's. One hallmark of Alzheimer's disease is the accumulation of amyloid beta peptide in the brain. The buildup of these plaques is linked to memory deficits and an overall decline in cognition over time. Brain scientists at RIKEN have developed a mouse model that exhibits these qualities. Close examinations of this model have already revealed a series of events in the brain that lead to the formation of amyloid beta plaques. Their latest discovery surrounds the role played by the protein α-endosulfine, or ENSA. One of ENSA's jobs is to close certain ion channels in the hippocampus, the part of the brain where memories are stored. But things go awry when ENSA is allowed to accumulate beyond normal levels. The RIKEN team found that ENSA also tends to reduce levels of the enzyme neprilysin, which destroys amyloid beta plaques. In excess, therefore, ENSA can create an environment that fosters the development of Alzheimer's. So, what enables ENSA to build up to these dangerous levels in the first place? Low levels of the hormone somatostatin. Somatostatin pumps the brakes on the production of other hormones throughout the body, including ENSA. Unfortunately, both somatostatin and neprilysin tend to decrease with age, which could explain why Alzheimer's usually occurs in older people. Findings confirmed elevated levels of ENSA in both model mice and in the brains of people with Alzheimer's disease. To suppress ENSA levels, researchers fed mice with diazoxide, a drug that keeps open the ion channels that ENSA tends to close. They found that while untreated Alzheimer's model mice showed characteristically poor memory, the treated model mice performed just as well as normal mice. A look at the brains of the treated mice revealed a lack of the hallmark amyloid beta plaques. More work is needed to understand how this cascade of events plays out in humans, but the findings do point to one potential way of preventing and treating Alzheimer's disease. That the drug used in mice is less expensive than current alternatives could improve its chances of being accepted around the globe.